talk. I mean, it's actually a great privilege to be invited back to the IoT I gave a talk 2 years ago, actually, this opening keynote, and I put up this slide because it was kind of early in kind of the main hype cycle that we're going through at the moment on AI. And I love this newspaper cutting. Oh, you know, the AI panic is here. Everyone was going, what is this AI thing? What on earth's going on? And lots of people predicting lots of things. And when Stephen Patterson reached out to me and said, you know, would you give another keynote? I said, well, you know, it's only 2 years ago since I last did it. I'm not sure how much more I've got to say. And then I thought, well, wait a second, an awful lot has happened in the AI space in the last 2 years. Arm's thinking's come on a long way in the AI space. Yes, I do have things to say. And if you think about the newspaper cuttings that we've got today, again, a couple of them here, you know, OpenAI, Oracle, and SoftBank have pulled together for this Stargate activity is one of the big headlines that's come across. These are enormous, great data centers, and obviously, I should remind people that SoftBank is Arm's majority owner, so this is an entirely unself-vested interest thing. But you know, this is one of many data centers that are being pulled together. You know, the sheer amount of investment going on in 2025 into the AI space is just staggering. There's lots of commentary about whether it's a bubble, but actually the level of infrastructure investment is absolutely unprecedented. And an awful lot of it is highlighted on data centers. And you know, we also had the plethora of announcements when President Trump was over in the UK about investments, and NVIDIA's boss at that point, you know, talked about how you know, the UK was going to be an AI superpower, and they were talking about investing in data centers or collaborating in the investment in data centers again in the UK. And again, slight self-interest to Arm in as much as all of the Grace Blackwells and the Vera Rubins that NVIDIA produce, the main CPUs in that are Arm-based, and we have a strong working relationship with NVIDIA. But you know, it'd be very easy from all of this to take the conclusion that you know, with AI, it's all about data centers, and certainly I've been in meetings in government where data center and AI are kind of seen as synonymous. And then I'm thinking, well, wait a second, I'm talking to an IoT conference, and they're the sort of people who don't really think that much about data centers. They're thinking about the edge of the network. How am I going to kind of reconcile that thing? And I think the way to think about this is, while there is this incredible investment bubble going on at the moment, we are in one of these big front-loaded investment cycles. There's a lot of commentary about how there's a kind of a parallel between what's going on now and the late 1990s when the internet boom sort of started off. My observation about all of this, everyone says, well, that boom became a bust. My observation is, if you remember back to what all of the futurologists were saying in the late 90s about how important the internet was going to be, and you look at the world today, I think most of those futurologists undercalled where it went. It just took a bit longer to happen. And I think you've got the same thing going on at the moment. You've got lots of futurologists saying where AI is going, and it's going to be absolutely transformational. And there's a huge amount of investment going in there without the business models necessarily in place. Much as in the late 90s, the business models weren't in place for the internet. But what will happen over time is once that investment goes through, it will end up being, I think, one of the big transformational technologies in history. But we've got to recognize the focus on data centers at the moment. The focus is on these really big generative models. And again, I was in a meeting with government recently where they started off talking about, well, we're thinking lots about AI, and they drew graphs about how the training of really big large language models was growing so much. And it's just kind of, well, yeah, training's all very interesting, but actually, you know, that's just creating models. It's actually you want to be using the models to do things, and that inference is really going to matter. And I think you're going to get a transformation once you get past that investment of people trying to work out what is what works, what are the possibilities? Can we create AGI? Can we create ASI? Can we really get to those sort of fundamental leaps in intelligence? That's a big part of it. But the actual how are people going to make money of it is still to come. And I think you're going to see a transformation, or a transition, rather, from the investment phase we're in today, which, frankly, all of the AI companies are currently losing money. They're losing money because they are burning investor cash, venture cash, or the cash stockpiles that some of the big hyperscalers have got, in order to try and find out what works, what the future opportunities are, because they can see where this technology is going, but they haven't quite found those killer apps that are going to turn into real money. But those are going to, I'm convinced those are going to come, but they're going to come in a much more distributed way. It's not all going to be, all of the work will go into AI factories. There's a really good paper that NVIDIA and Georgia Tech put out as a preprint a few months ago, which is titled something like Small Language Models of the Future of Agentic AI. And I think that made a very compelling case that what's being built at the moment are really big do-everything models. And in reality, an awful lot of the agentic uses, which is how I think AI is going to play out. It's going to do things and talk to other parts of the network and be completely connected, and machines talking to each other. All of those don't need that enormous single capability. One analogy I heard somebody use on this is those of you who are familiar with The Hitchhiker's Guide to the Galaxy. Marvin, the paranoid android, spends his entire time going around, here I am, the brain the size of a planet, and they ask me to open a door. Well, if you open a door, you don't need a brain the size of the planet, and you don't need an AI model the size of the planet if the agentic thing you're doing is smaller. And so what I think you will see, excuse me, I'm on the tail end of a cold. What I passionately believe you will see is, yes, you will see the really big the really big foundational models progressing, but you will see distillations of those and smaller subsets and small mixtures of particular application-targeted spaces and mixtures of agents deployed out at the edge much more, because I think that will actually be much more economical, because using a really big, highly capable large language model to solve a relatively simple problem is just going to be power inefficient and is just going to be cost inefficient as a result. And so what you will move as we move into the world of agentic AI is into monetization phase that will see AI, yes, in the data center, but across all of the edge as well. And that very much is what ARM believes in. And that's why we've been investing. I've got my slides in slightly wrong order. And so it's worth reminding people that kind of the difference between the amount of work it takes to do training and the amount of work it takes to do inference. And this data, which I did actually get by asking ChatGPT how much work it took to do these things. But I then checked it, because never believe everything ChatGPT tells you. But training something like GPT-4, GPT-5, order of 10 to the 25, 10 to the 26 flops. It's about the amount of energy released by 1 kiloton nuclear bomb, for those who track these sort of things. It's an enormous amount of energy to create those things. A typical GPT-5 chat output of maybe 1,500, 2,000 tokens, order of 10 to the 14, 10 to the 15 flops. That's a ratio difference of 10 to the 11. Now, we're mostly scientists, I would imagine, in this room, mostly mathematicians. We're pretty numerate. 10 to the 11, yeah, we know that's quite a big difference. I kind of asked, well, can you give me a visualization of that? And we did some quick back-of-the-envelope things. If you compare the diameter of the Earth with the width of a human hair, that ratio is about 10 to the 11. So that shows you the difference between the amount of work it takes to do training and the amount of work that it takes to do the inference. And I believe that inference is going to be the thing that matters. There's going to be a lot of it. But you turn around and say, well, 10 to the 11 is such a big number. Maybe even then, they're not going to be used, these models aren't going to be used so much that, that it'll make up for the cost of the training. And then you go, well, there are about 10 to the 10 to 10 to the 11 internet searches per day. So if you take that and say, well, it's about 10 to the 11 ratio, a couple of days' use of one of these models by the entire world will make up for its training. So actually, the majority of the compute, I believe, when this all settles down, is absolutely going to be at the edge and in inference in the longer term. That's where the real money is going to happen, because building a model is creating a tool, and creating a tool doesn't make money for anyone other than the tool maker. People buy tools in order to do things with them, and that doing things with them is inference, and that inference will be actually the thing that pays for all of this activity. And that, some of that will be in the data centers, some of it will be distributed across the agents and the edge using smaller models as well. That's how this, I believe, will play out. And this is why ARM has been investing in putting in technologies into our CPUs. To do this, we've recently started deploying our SME2 architecture, which is our matrix multiplication extensions. We actually recognize now a matrix as a first-class data operation. There is a 4 kilobyte array sits in there that you can do out-of-product operations on. And this is giving sort of 4 to 5x performance improvements on things like speech recognition, the encode phase of Gemma 3's LLM, a bit less in audio generation. But these are substantial multiplications in a time when most compute, if you get 10% on a generation, you're feeling you've had a good day. There's a lot that you can do with acceleration in this area. And our belief is, as I said already, that AI must happen at the edge for the reasons I talked about from an economics point of view, but also for things like privacy. I talked actually 2 years ago when I was here, I talked about use cases where you're taking raw feeds that you wouldn't want to share in the internet and inferring information from that. And actually, as we get to this idea of your AI assistants, they're out to help you. The whole thing that AI thrives on is as much context as possible. That's what actually lets it give you information that's relevant to you. And so as we end up having assistants in our homes, we are going to find ourselves them watching us all the time. So background AI, gathering information to provide things for you. This might sound a bit scary, and from a security point of view, truly terrifying. But that is actually going to be one of the big tensions. And you certainly don't want a stream of everything in your life going onto the internet all of the time. So this is go way beyond things like just watchwords. Latency matters, and we talked about cost and efficiency. I think democratization also matters because these data centers are going to be so expensive, and there's going to be a lot of opportunities for other things as well. And one of the other big things that's definitely going to happen at the edge of the network rather than data centers is the growth of physical or embodied AI. Nowadays, we're at cars that very commonly kind of that level 2+ with driver assistance, they're able to steer, but you still got to keep your hands on the steering wheel on the motorway, but it's able to do lane changing for you. It's moving now towards genuine conditional automation. And if you spent any time in places like Austin, you'll have seen things like the Waymo taxis that are actually able to drive you around, and they are completely genuinely driverless. So that embodiment comes here, and I put up a slide just showing the amount of compute requirement. And really, my takeaway from this is that the kind of up to about the level 2+, the computational requirements of these things is very much kind of what you would expect in a high-end PC, a sort of client-type system. But as you start getting to the level 3, level 4 autonomy, this true autonomous systems, these are really moving into server-class systems. They will be server in the boot. And an awful lot of opportunities there. And you're going to get HBMs, and you get all of the wherewithal that we're seeing with large language models. And of course, embodied and physical AI goes beyond just automotive. We are seeing the rise of the robots. I'm sure there's a film about that. There are robots in various forms. All the cliches bring in humanoid robots, and there is a truth to humanoid robots because we live in a world that was designed for humans, and therefore robots need to do general things. Making them humanoid makes a lot of sense. But in a lot of places, It makes no sense doing that because actually you want to be in a different environment and be specialized for a particular thing. And it kind of ties in a little bit in the same way that I was talking about small language models being specialized to particular tasks as a way of using AI out at the edge. I think you'll see the robotics similarly being very much bringing in AI but tailored to particular spaces. And it is a sad fact, but the reality is that also the military is going to be very, very interested in this sort of embodied AI. And there's nothing like a war to drive innovation in this space. So that's kind of the landscape, but we're here partly to talk about security and trust. And our view, and ARM has been saying for a long time, that the limits of what we're going to do with computing is going to be set by the degree to which you can trust it. And we are bringing computing absolutely into the center of our lives. And I want to start with a quote here from Ollie Whitehouse, who is the CTO of the National Cybersecurity Center, who I asked him for a quote on this because he mentioned it to me in private recently. And I said, well, that was what I said 2 years ago at the IoTSF conference. It'd be nice to prove that I was right. And that is that the cybersecurity of AI systems is 90 to 95% non-specific to AI, i.e. hardware, software, and systems and operational security addressable through additional approaches. In other words, while AI is an exciting new area, everything that we've been doing in security to date is relevant to this AI space as well. There are other things going on that we have to worry about, and I've got a slide on that in a moment, but actually things like memory safety, things like worrying about code reuse attacks, return-oriented programming, all of that sort of stuff is just as relevant in the world of AI because the attacks actually just as much are about influencing the data on the way in or stealing the data on the way out or stealing the models. And this slide here, in interests of time, I'm going to go over this very quickly. You've got training data, an AI model, and when it's in use, you've got inputs and outputs. Very simple stuff in the green. The stuff in the orange are kind of the threats that you can anticipate in an AI system, such as the data poisoning on the way in on the training of the model so it could be corrupted, or stealing the model. Certainly one of the things when you talk about putting out models, AI out at the edge, is those models are valuable, and I'll talk about that in a bit. But again, that's no different from stealing your data or anything else out there. Similarly, denial of service attacks, exfiltration of data, all of those are kind of things that we've always been worrying about security, whether it was AI or not, and those still really, really matter. There are new specific AI related attacks that are associated with can you reverse engineer a trained model to find out people's personal data, and things like model inversion and membership inferences as particular attack vectors. But those are kind of at a higher level. As a computer architect, I find myself looking at it going, actually an awful lot we've been doing in security is just as relevant in an AI world as it has been all the way through. And what we have seen is that the emergence of AI as a fundamental driver of future systems has expanded the interest in ARM's confidential compute architecture. ARM developed its confidential compute architecture primarily aimed at the challenge, and this is what confidential compute is mostly always been about, the challenge of if you are putting your systems on the cloud, how do you know that you are running on a trustable platform and be able to attest that that platform is correct? And that's been kind of where confidential compute came from. But we've seen in the last 2, 3, 4 years a massive uptick in the interest of that confidential compute coming into the client space, into stuff that will be deployed at the edge of the network as well. And this really comes down to the fact that the models that are being produced, if you talk to OpenAI, they will tell you, that they have an enormous amount of intellectual property in those models, not just the weights, everyone thinks about the weights, but actually the architecture of the models are secrets and are more persistent secrets than the weights. And if somebody can extract those, then essentially they would lose significant amount of their intellectual property, and that's pretty bad for a company that is effectively based on its know-how and its technology. So, they are really worried about that, and they're saying we would like to deploy at the edge for a lot of the reasons we've just been talking about, but how can we trust it? Because, this is our crown jewels, and if we lose it, we're in real trouble. And so being able to protect those expensive models is a fundamental requirement. And in addition, AI is going to be operating over more and more of our data. And that brings together lots of user data, but also service provider data. Because essentially, you've got the foundational models, and then you've got the AI application providers running on top of that, and those guys are providing their own parts that go into the prompts, that go into the RAG that gets looked up by the AI. And those, that is, again, confidential data, and people are very, very worried about losing that. And that is shown a substantial increase in the interest in confidential compute out at the client edge, out into the IoT space as well, where people are looking to have AI-enabled IoT things, which will allow these models to go out to the edge. And confidential compute is one of the key use cases of ARM's realm management extensions, which have been starting to be deployed now in servers and will be coming into the client devices over the next couple of years. But on top of that, that technology also allows non-secure protected pipelines where there are agents downstream from the CPUs that are actually doing processing on the data and are protected from that work in progress being seen by the CPU and being able to dynamically allocate memory within that. And again, this ties into an AI space in a world where very often the CPU will be talking to a stream of AI accelerators going forward. And we also support things completely separated from our CPUs as well as part of our realm management extensions. John talked about memory tagging, and I'm aware that I am in danger of overrunning. So I'll cover this briefly, but our memory tagging extensions, which is kind of our target towards memory safety. We've been talking a lot about memory safety, and we've been working at the University of Cambridge for a long time about it as well. This stuff is now actually really being deployed. If you buy some high-end Samsung phones for your Android space, or as has been referenced, if you buy the latest generation iPhones, you will see that memory tagging technology now in there. And we're seeing it being used for two very distinct use cases. The first is essentially faster and more efficient address sanitizer. Address sanitizer as that fantastic software tool to allow you in the lab to look for memory safety issues. Having memory tagging actually running live in your system allows that to be deployed in the field at a tiny performance overhead. And it doesn't provide, if used in this way, it isn't providing huge amounts of additional security, but it is effectively looking for potential vulnerabilities, the things that the memory safety issues that are lying latent in perhaps the less used code paths out there. Hot code paths get exercised all the time. You probably think the memory safety issues, even the subtle ones, will get exercised out of that. But there's a lot of cold paths which actually get used relatively rarely and get used perhaps rarely, and even more rarely with real data, where actually being able to spot those and have bug reports going back to the apps developers to allow them to be fixed, having had real experience in the field, allows crowdsourced debugging of these things going on. But as Apple has announced with its memory integrity enforcement stuff, people are building on our memory tagging extensions in order to create actually more secure, more fundamentally secure systems in terms of memory safety. And we're seeing that as a big step forward. And so that's kind of where we are today. I'm going to do something actually quite new. This is the first time we talked about either of these two technologies in public at all. A little bit of a coup for the IOTSF there. We've just started announcing these. We put these under the title of Future Architecture Technologies. Obviously, when I came up with that name, I didn't do the acronym correctly because it's fat. But future architecture technology, this is stuff that is coming down the road. We're not making big announcements of it. It's in this product now or whatever, because it's going to take time for the software world to adopt it. And the real reason we're talking about it is for software developers to start making use of it with models from us. And then you're going to see products using this technology in the next few years. And this is kind of based on our experiences with the memory tagging that we've got today, but also from the Morello program, which it was ARM's, or is ARM's implementation under the DSPD, Digital Security by Design program funded by UKRI. We pulled together this demonstrator of Cherry technologies. And while that's still an ongoing piece of research, while the program itself has wound up, there are still quite a number of people researching it and making use of the chips that we've generated out of that. It's clear that the route to deployment of that is still quite challenging, but we've learned from it and we've taken some lessons from that. And we've taken some lessons from what has been good and bad about our memory tagging extensions. And two of our future architecture technologies, and this stuff is actually on our website. You can read a blog about it, and the specs are going to be coming out in the next few months. We're taking our memory tagging technology and enhancing that by putting the tags actually into virtual memory rather than physical memory. And you might go, what's he talking about? The challenge we've got is that in the client space, people are prepared to carve out around about 3% of their memory in order to have a place to put your tags in. That works pretty well. People complain about it because 3% of your memory, they think they could be doing other things with it. But in the client space, that's acceptable. If you talk to the server space, their first response, once they stop swearing, is to basically say, do you know what proportion of our bill of materials and our total cost of ownership your memory is? And taking 3% of that is utterly unacceptable. And certainly taking 3% when you're not going to use it all of the time, don't even think about it. Come back with a solution that allows you to pay as you go. And so we are moving the tags from being in physical memory into virtual memory, which allows that pay-as-you-go model. And it will actually essentially allow more people to take the benefits that we're seeing out of memory tagging technology and use it in a wider range of spaces where that memory cost at the moment is prohibitive. We've also, and this is perhaps more significant, one of our future architecture technologies is we are enhancing our permission overlay concept, something with the incredibly unmarketing title of PoE2, Permission Overlays version 2, which is introducing a lightweight compartmentalization scheme. One of the big promises, one of the big things that was really interesting about Cherry, one of the things we really loved about the concept was the idea it was a way of doing lightweight compartmentalization. And while moving to a full deployment of Cherry is proving quite difficult, and is still very much a research program, the idea of can you offer a way to do lightweight compartmentalization now that's relatively straightforward to deploy is something that would be asked for. And to give a kind of a motivating example for this, if you look at the world today with no compartmentalization, you take an application. An application these days isn't just one guy writing some code. It's putting in lots of middleware, it's putting in lots of libraries. All of those things sit together, and you are trusting a whole heap of libraries that people are built on. And if there's any vulnerabilities in that, then your app will get attacked. And we saw this with stage fright a few years ago. And you were working between the library and your main application, and effectively the stage fright gave a way of getting out into the rest of the application, compromising your application completely. And what we've seen, and this is well established, is that people say, well, that's not acceptable. I'll compartmentalize my software by moving my libraries for other things. I'm using an example here of a codec into a different process, and I will run my application. Then when I call that library, I'll go through the OS kernel, it'll do a process switch, or switch a whole bunch of page tables, and then you'll go and run the library, and then you'll come back again, and you hope to God you're not doing that too often, or else you're going to spend your entire time switching between processes, but that's what people are prepared to do for security because of the vulnerabilities here. And this has got a noticeable performance overhead. So what we're introducing, I'm going to go through this very quickly. What we're introducing with our PoE2 is effectively an overlayering of the permissions based on so overlayering of the ordinary permissions that are used by an OS kernel, and those permissions are typically used for the lifecycle management of pages. It allows you to do copy and write and all sorts of other dynamic coalescing of memory, all of that sort of stuff that operating systems do. They need the permissions for that. But what you really want is a set of permissions that apply, that say, in this application, at this moment in time, I want these additional permissions on top of it that further restrict what the OS has given you. And so just to cut to what we're now doing is we're providing tables that that essentially encapsulate what areas of memory you are allowed to access based on where you got the code from, and in terms of which pages the code came from, and also in terms of a temporal measure, which is essentially a sub-ACID that lives as part of your, I'm in this phase of execution of my process. So I'm currently in my virtual machine. No, I'm currently I'm currently in my runtime. No, I'm currently in the translated code. And those are two different phases of execution. And the application is able to swap those dynamically. And we're putting in tables that essentially police those changes. So what we're building on top is a new permission scheme that sits on top of the traditional permissions that an OS uses, which allows splitting up of a single address space into smaller areas of memory, so that when you are running your codec code, it doesn't have access to your main application heap, and vice versa. But doing that all within a process to allow you to have much faster switching between different these different phases of execution, and to stop you being able to take a library that came from somewhere else and use it inappropriately, because essentially the permissions associated with this are looked up by where the code came from, as well as by your phase of execution. And there's some tables there, which in the interest of time, I'm going to leave this. These will be available to people to have a look at, leave people to go through it. This is being written about. The specs are going to be released in the next couple of months. And we're very excited about this. We're getting a lot of traction from a number of our partners who think this is actually a big route forward to, again, actually interestingly, improving performance while allowing the same level of security as they get with the application by application level switching that is used today. And it's kind of similar concepts as we had as one of the use models for Cherry. And we are continuing to work with Cambridge University to make sure the compartmentalization principles that we're working on here are compliant with where Cherry thinks about compartmentalization, so that if Cherry technologies do end up being deployed in application spaces, the work here would also then translate going forward into this new area of technology. So just to wrap up then, we are in extraordinary times in terms of AI, this AI explosion, this incredible exploration of where computing and AI is going. I don't think we've seen anything like it. We're at this investment phase at the moment. The monetization is still to come. At some point, the laws of economics are going to come back in, and people say, well, actually, how do I do this efficiently? And that's where the engineers come in and say, I don't need a huge model to do a small task. That will move a lot of the AI, in our opinion, out onto the edge. We're trying to work, well, we are working with pretty much all of the partnership, all of the semiconductor industry in this area. One of the lovely things about working for ARM as a licensing company is that we get to talk to just about everybody in this industry. And we're very much, I see us as providing a lot of fundamental technologies, but all of this has to be based on trust, and all of the work that we're doing on computer security is going to be absolutely fundamental to realize the full potential of AI. Thank you very much.